I'm Siegfried Engelmann, Senior Educational Specialist at the University of Illinois. For the past several years, I've been working with Dr. Bereiter at the Institute for Research on Exceptional Children, developing methods and curricula for educating culturally disadvantaged children. In this film, you'll see the end product of some of our efforts. You will see children sitting down and showing off what they could do in arithmetic. That's what it is, showing off. No attempt to teach, just to show what they've learned over, for some of them, a 2-year period, and for others, only a 1 school year period. That's not very many hours when you consider that their lessons lasted for only 20 minutes a day. Now, the method that I developed and that you will see in this film is basically deductive. It is not inductive as many of the current programs are. It is based on the idea that you can work with minimum statements and teach the application of simple deductive rules that give a very precise understanding and a very precise meaning to the statements of arithmetic. And that's what you'll see. You will see the children using these methods, and the film shows how far they go. Now, what to watch for in this film is primarily the interest, the spontaneity, and the general intuitive understanding, the problem-solving set, or whatever you want to call it, of these children. During the initial stages of this program, critics often point out that it's a lot like a Chinese grade school, that there is some repetition, and that it seems that to them anyhow, that the will of the children will be stifled. They point out that children subjugated to this kind of program will most certainly have their creativity squashed and their interest dampened. You be the judge. Watch the film. Note any signs of creativity. See whether or not they know how to solve problems. See whether or not they have an interest. See whether or not they take these things seriously and are able to process the problem intuitively, quickly, as if it means something to them, as if they've taken these problems home. You be the judge. Certainly, the results that you will see on the film are not completely indicative of what could be done in the school program, because we had, in many ways, the advantages of an experimental program, but this is no reason to write them off and say, oh, well, that's an experimental program. Because so long as the problem exists and so long as a solution apparently exists, then it is incumbent upon us to demand that the problem be solved in the schools. Okay, let's do a little of these. I'm going to get you right off the bat. 8 plus 2.
10.
8 plus 2 equals 10. Say it.
8 plus 2 equals 10.
What's 10 plus 2?
12.
12 plus 2.
14.
Good. Here's a hard one. 7 plus 2.
9.
If 7 plus 2 equals 9, 7 plus 3.
10.
7 plus 4.
11.
7 plus 5.
12.
Okay, that's pretty good, but pretty easy. Wait till you see this one. Are you ready? What if I had something like this? 6 plus, look at that plus, 2. Yay! 6 plus, how many equals 6?
6 plus 0 equals 6.
Sure, so what could I do? Erase that B and... Good. What if I had something as hard as this? 7 plus R equals 1. Oh, sheesh. Goodbye.
4.
That's it. Yo. 7 plus how many equal 11?
7 plus 4 equals 11.
Yeah, how'd you work that out? You got 7, you want to get to 11.
8, 9, 10, 11.
4. Okay, one more. Here you go. 9 plus... Oh, boy. How many equals...
5.
5 is right. 9 plus how many equals 14?
9 plus 5 equals 14.
You guys think you're pretty tough, eh? Well, I hate to do this to you, but goodbye. Goodbye.
Bye.
Oh. Huh?
8 plus 4.
8 plus 4? 12. So I just write it down like that. You missed it? Oh, the 10's got to go over here?
40.
What do we have? Oh, 10 plus 30 equals 40. Oh, that funny truck. Yep. Okay, and then what do we got? Yeah, 40 plus 10 equals?
50.
Yoo-hoo! So what do I have up here? I've got
52.
50 plus 2 equals?
52.
So what should I put down here?
52.
52. What's 38 plus 14?
52.
52. Do you want to do one more, though?
Yeah. Can I work?
Oh, I don't know. So I just cross these out and put a 12. Okay, what do we... 20 plus... Yeah, 20 plus 10 equals 30. So 30 plus 2 equals... What's my answer? So what do I write down here? Right. Good. What's wrong? Oh, well, what did I say? Oh, 32. Okay, I lost my head. Now let's try a little different kind of action. What about this? Oh, goodbye. That's right. Yeah, you're ending up with 1, so which one's bigger, 9 or B? 9. Which one's smaller? How much smaller? What's one smaller than 9? 8. All right, here you go. I'm getting tired of this stuff. Here you go. Do. Goodbye. 14 is right. Oh, boy. I can't seem to get you guys very well tonight. How many minus 11 equal 3? All righty. That's just too easy for you. I can see. What if I gave you just something like this? 10 minus 3. Oh, boy. I can't get you on that kind of stuff either. So now, I'll put something in there that, well, watch this.
12.
I thought I'd get you. I thought you'd think it was a plus sign. But you didn't think, what kind of... Yeah, what kind of sign is that? Okay, what if I did something that's much harder than that? What if I did like this? 5 times R equals 20. Yeah, count by 5s. How many? Yeah, whoa, okay, that's good. What if I had it like this? What if I had 5R equals 20? Could I erase the R and put a 4 there now? No, why? Yeah, why couldn't I erase the R there and put a 4? What would it say?
54. We don't want 54.
What do we want to say?
5.
Yeah, but what do we want to say?
5 times.
5 times 4. So if I erase that R, I also got to put a little bit time sign right in there like that, and away we go. Okay, that's pretty good. Now, what if I gave you something like this? We want to find how many squares are in this thing. We know it's 3 this way, and it is 7 feet this way. We want to know how many squares would be in the whole.
Cut by 3.
21 is right. How many squares? 21 squares. Okay, well what if I gave you something like this, and I told you that it's 4 feet on this side, and we're not going to tell you how many feet. What can I put for we don't know? Okay, a rectangle, or let's put a C, all right? And I'm telling you that the whole thing has that many squares. Is that right? 6 is right. Yeah, count by 4s. How many times do you end up with 24 4. Let's do it.
4, 8, 12, 16, 24.
How many times?
6.
Yeah. Very good. Young Lander, you are a tiger again today. 6 feet on this side. All right. So, what if you go into a store and you say, I want to buy a can of beans. And the guy says, that's good because 4 cans of beans cost 40 cents. 4 cans cost 40 cents.
4 cans equal 46.
Okay.
Stop by 4. How many times?
What does a can cost? 10 cents. That is right. Okay, so I can't get you on that one, all right? Remember what I can get you on. Oh, boy. Now, wait, hey, here we go.
-1.
Oh, boy. That's right. -1. What about this?
-2.
Oh, boy. What's with you guys? Have you been working on this?
No.
Haven't you? Haven't you been? Who's been thinking at home? You? You've been thinking. Well, that's it. See what happens when you get thinking? What happens when you think?
You get smart.
You get smart, and that is true. And you work hard. Now, here's who knows what the name of this thing is called? What is this thing called? Yeah, this is dividing, or this is called a fraction. Is this fraction less than a whole or more than a whole? Is it less than a whole? Is it more than a whole? Huh? It is a whole. It says make. That's right. It's the same.
Make 7 and quarter 7.
So it equals 1. What does this fraction equal?
1 whole.
1 whole. It says make A. We don't know how many A is, but it says make A and color
Color
A.
A.
So we color the whole thing. What about this fraction? Is that more than a whole or less than a whole? More than a whole. It says make 7 and color
Color
8. What about this fraction? Is that more than a whole or less than a whole? Less. It says make 7 and color all 7 of them? No. How many do we color?
4.
4 is right. Now, what happens when we have a big cagey fraction like this? Oh, well, it was fun while it lasted, gang. Yeah. Can you figure out how many holes it equals? 2. How do you figure it out? Say it.
Number 900 times 10 over 18.
And you counted all 8 times?
2.
No, and that's the answer. B equals 2. What about this one? 5 is wrong. 6 is right. 6 is right. You had it, yeah. Very good. 12 over 2 equals how many holes?
6 holes.
Let's try one more. Okay, are you ready for one more? Can I make this one a little bit tougher? I'll make this one really tough. Oh, boy, that's... Oh, you guys are just too much. Okay. That one didn't work out too well. Let's try this one. 9 is right. Who said 9?
Me.
Hey, 9. 9 is right. Very good. Well, you said 9 too, didn't you? Yeah? No, you said 8? Oh, dear. Oh, no. You were close. It's hard to count when everybody's counting in your ears. Okay. What about now if we have something like this? Do you like that? Huh? Is that pretty good? Huh? 4 into...
4.
How about 4? How many times to get to 16?
4.
4 times. Very good, very good. You know how to work that kind of thing, too. What if I gave you something like this? Go. Go.
5.
What about this? Go.
3.
3. Go.
5.
Right, comes that as sharp. She's got a picture of that chart right in her head. Okay. Okay, and now for a really hard one. Ready? 8 is right. I can't seem to fool you very well on those 10s anymore. I think you're getting too tough. Okay, let's...
Now when you give us 10 times 8 equals
10 plus 80. 10 plus 8 equals 80.
80.
Yeah, 10 plus 8 equals 18. 10 plus 4 equals 14. 20 plus 7 equals
17.
20 plus 7 equals
70.
20 plus 7 equals 27. 40 plus 7 equals
47.
Sure. And 10 plus 8 equals
18.
18. That's right. Okay, now here is something that's really pretty tough. How do you like this? 1 over 8 plus 1 over...
You.
Hmm?
You had somebody to put an A.
What, don't you like it this way?
No, you can't.
You can't have those. Why? Oh, you have to... Oh, tell me what to write. What do I write? A. We're talking about A's? 2. 2 over A. Okay, getting tougher. Four on the bottom? We're talking about 4? 10 is right. One more.
That was more than
B on the bottom.
13.
Yo, ho, ho, and away you go. Boy, that was very good. All right, now let's just move right on into the hard stuff. Equals 6.
Turn it upside down by 3 over 2.
By what?
2 over 2.
What do I multiply?
3 over 2.
3 over 2.
When you
Good.
do on one side and each side, you have to multiply by 3 over 2.
Multiply by 3 over 2.
6 over 1.
What? I didn't hear you.
6 over 1.
Yeah, 6 is a fraction. 6 over 1. Very
Count
good.
by 3, 2, 6.
6.
Count by 2, 3, 6. 2, 4, 6.
Yo, 6.
Count by 6.
Wait a minute. Wait, let me write down. What do I write now? 6 over 6A
Equals. Count by 6, 3, 6, 12.
Almost.
8, 20.
He's got it. You never learned how to count by 6, but he knew it. Count by 6 3 times. 6, 12,
18.
18. Very good. 18 over
Count by 1, 2 over 2.
2. Okay, very good.
Count by 2 times 2, 4, 6, 18, 12, 14, 15, 16, 9.
9 is right. 18 over 2 equals how many holes?
9.
So 1 whole A equals
9.
9. 1 whole A. Okay, let's...
How come we don't do no factory?
How come we don't do any
No,
factoring?
we won't. I would do flash. Why don't we do no factory?
I don't think I like to do factoring with you.
I want to do some flash.
Fractions? What
Yeah,
do you want to do?
fraction X. Oh!
Fractions. Uh-oh. Well,
So?
I heard him. Okay, here we go. Here, I'll let you make up a little fraction story. You go into a store and you say, I want to buy a pie. And the guy said, that's fine, because 1/4 pie costs 5 cents. 1/4 pie costs 5 cents. How do I write it up?
Wow.
4 P
Equals 5.
5. Go.
Turn it upside down by 4. What are you doing? Wait a minute. What's 5 by 4?
4 over 1.
5 over 1.
5 over 1. Go.
Count by 4. 1 times 4.
4.
Count by 1. 4. 2 over 2.
4.
Count by 5.
20 is right. 20
Count
over 1.
by 1.
20 over 1 equals 20. Right? 20 over 1 equals 20. So the answer is if 1/4 pie costs 5 cents, the whole pie costs 20 cents.
Now,
What's wrong?
you can't
that better? Is that better? Would you rather, do you think 20 cents is right instead of $20? That sounds right to me. Okay.
What about a Hey, Justin's coming up.
What did you want to do before? What was it you wanted to do?
Flashing.
Well, we were factoring. Okay. Goodbye. Yikes! Goodbye.
What's the matter?
What's the matter? That's the matter. Threes is right. What number can you count by to get to all of these? Three. So I just multiply this by 3. There I changed it. Divide by 3 where? Here?
Yes. Divide by 3. Divide by 3.
So this equals 3 times the quantity.
2.
2. A
Plus.
plus 3 B plus 1 C.
3 times the quantity. 2 plus 3 plus 1 C.
What more? What more? Okay, getting me. Here we go. 40 A plus 90 B plus 20. I didn't even get them all down yet. Plus 30 D. That's a D. Can you read it? 10 is right. So I multiply by 10. I've changed it.
Divide by 3. Divide by 2. Divide by 2. Divide by 2.
So it equals 10 times the quantity 3. D. 3D plus 4. A plus 9. D plus 2. C. Very good.
Times the quantity 3D plus 4A plus 9D plus 2C. And 2C.
2C is right. Very good. Very good.
Plus 4A plus 9D plus 2C.
Very good. That was really tough. And here, I think this will be about the last one that we do. We're finishing kind of early. You guys are so fast, I'm getting tired of giving you problems. Here we go. So here's going to be it, and this is going to be tough. C plus M equals R. What are we doing? Hey, come on, Tina, what are we doing? Adding. So which one of these is big number? R is right. When you add, you always
End up with the big number.
Okay. So what if I want to find out what if I want to end up with C?
C equals start out the big number R and minus M.
That's right. C equals R minus M. What if I want to end up with M?
M equals start out the big number R and minus C.
Minus C. What if I want to end up with R over here?
R E add.
Yeah, I have to add.
M and C.
M
and C.
M and C. Sure, I have to add if I want to end up with the big number. This one, just like that one. Very good. You guys are tough today. All right, and now we'll do something that we have not done in a long, long time, and I honestly don't expect you to be able to do it, because this is really too tough. But we'll do it anyhow. Do these together. Work them together. A minus B equals 0. A plus B equals 10.
2 plus 2.
2 plus 2, does it equal 10?
5 plus 5.
That's it. 5 and 5. A equals 5. I can put a 5 in there. And B equals 5. 5 minus 5, does it equal 0? Yeah. 5 plus 5, does it equal 10?
Yeah.
Very good. This tells you you end up with 0, so what do you know about these guys? They have to be the same size. You want two numbers the same size. When you add them up, you end up with 10. One more. Getting tougher. Now what does this tell you? This tells you when you add them up together, what happens? Well, look. When you add A plus B, what happens? Well,
10 plus 10.
Yeah, but you don't know how big they are. You don't know if they're the same size or not. All you know is that when you add them up, what do you end up with? 14. You add them up, they end up with 14. This tells you how big they are right now. A minus B equals 2. One of them is 2 bigger than the other. 2 bigger than the other. Oh. Well, what if this said like this? What if this said A minus B equals 0? Then what would you know about it? Yeah, say it.
7 plus 7.
You know they'd be 7 and 7. Okay, but they're not 7 and 7. One of them has to be bigger than 7, and one of them has to be smaller than 7. Oh. That's it! 8 plus 6. Very good. Good thinking. This one is 8, and this one is 6. Very good, Cosetta. Okay, now, that's right. This one's an 8. 8 minus 6 equals 2. You guys do a good job. I'd like to thank you very much. Thank you. Have a little chalk. Thank you. A little chalk action there. Thank you. Thank you. Thank you. Thank you. Come on. Thank you. Good job. Very good. That's it.